This is Michael Romero with the longest common subsequence of two strings. Let me go how I generated my input data. Um, I created a dictionary alphabet for an alphabet of 26 characters, and I made a string list, a character list of 100,000 characters two times, and I generated random numbers in the range of the letters dictionary to generate the random characters for each string. And I would write that to a file so I can consistently use it later. And this is just loading the file to character lists, which is used by both the brute force and the memoized version. During the brute force version, it first loads the strings into character lists before anything else is done, and then it runs the algorithm with these different input values for n, which will limit how far it looks into the string. It just calculates the time. It doesn't I already proofread the result. It's accurate, and it just averages the sum of the 10 trials. The actual algorithm, it generates a limit for the number of for how long the primary sequence is, and and it also generates a binary mask to generate the subsequences. The mask is incremented, and then a binary mask is generated from that incremented integer mask, and then it creates a sequence 1 from the subset of characters from the first string. And then it goes through the sequence in sequence 1 and in string 2. And if they match, it increments the pointer for string 1. Regardless, it increments the pointer for string 2. And if the pointer for for the sequence 1 reaches the end, it checks if the length of the subsequence is greater than the current maximum, and then it writes it to the current maximum, and then after all that, the mask is incremented up to the limit, which is power 2 to the n. And that's this algorithm for brute force. It's a very high complexity. I stopped waiting after 22 for the first trial, and I only did up to 20 for the 10 trials, because it got really big. For the dynamic programming one, the strings are loaded in the same manner before anything else. Then it runs these trials. At 40,000 characters, it runs into memory problems and crashes. So there's that. For the dynamic programming, it creates the B and C arrays. One is a length index for the different subsequences, and the C array is the direction for backtracking the subsequences. And it uses the algorithm to iterate referencing the previous entry if it's an improvement or not. And first it does generates the B and C matrices, and then it traces back from the index n by n from the B matrix to generate the new string. And let me just run this so you can see. I'm not going to run the gen letters because I don't want to lose my input. And it's very fast for the first few, but it starts taking time, and that's what the output was for my application. And this one's since I increased the the string length so much, it stalls out faster. So yeah, at 1,000, it's already getting a little long, and I'm not going to run the whole thing because that would take hours.